Hey, what is up everybody? My name is Rahul and in this video we'll be talking about psychic signatures vulnerability that you'll find in almost every cybersecurity portal that puts out cybersecurity news, and it has been given a CVE of 2022-21449. We'll be talking about the highlights and what caused this vulnerability in the first place. Now it has been given a CVSS score of 7.5. That's quite high. The vulnerable versions are 15, 16, 17 and 18. Now this vulnerability was in how the ECDSA digital signature scheme is implemented. Now ECDSA stands for elliptic curve digital signature algorithm and is commonly preferred over RSA because there are two ways in which generally the digital signature scheme are implemented. The first is ECDSA, the second is RSA, but RSA requires numbers that are quite huge in length. ECDSA can accomplish the same thing in a short range of numbers. Now before I move forward, I'd like to ask you a question. Is 0 equal to 0? That's true, right? Because this is the basis of this vulnerability. As you can see, this is how easily this can be exploited. Now let's move on to the analysis part. Now let's just see how a ECDSA is implemented. Now generally what will happen is a user or the sender will send a message. Along with the message, he'll send in R and S. Now what are R and S? In case of ECDSA, R and S are referred to as the signatures, and these are generated on the basis of the message that is being sent, which means R and S are generated on the basis of the message that is being sent, a base value G which is specific to elliptic curve cryptography, and a random value K. So there are a few variables upon which R and S value are decided. Now these both are sent to the recipient. Now what will the recipient do? The recipient will generate a complex equation based on the private key and the message that was provided, which is here, and it will also multiply that complex equation by another equation that is derived from the value S. It will multiply both of them, and then in the third part it will check if both of these are equal to R. If they are equal to R, it will say yes, the signature is verified. Otherwise, it will say the signature is invalid. The problem is when R and S are both 0. So for example, if I send in R and S as both 0, what will happen is this will become 0 and so will this. So 0 will be equal to 0. But the thing is, in most of the libraries out there, R and S values are specifically checked to ensure that R and S never become 0. But in this case, what happened was it wasn't checking if R and S was equal to 0, and this is what caused the vulnerability in the first place. This was introduced in Java 15, and Java 15, 16, 17, 18 are all vulnerable. So how can you mitigate it? You can mitigate it by applying the critical patch of April 22 by going to the Oracle's website. So thank you guys, that's it for the video.